Hello everyone, welcome to my channel, Mutlu Learning Hub. And today's question is, what's statistical learning? So we will describe the statistical learning, and then we will dive into supervised and unsupervised learning. Then we will learn two important methods, parametric and non-parametric. So we have this question. Let's say we have a bike station and we want to answer how many bikes will be rented tomorrow if it's sunny and 25 degrees. And we have the past data. So here the input is the temperature and weather. And we can have even more. We can have the day of the week. Day of the week and so on. And what's the output? We want to know the number of bike rentals. And if we want to write this in general frame, we want to predict an outcome. Y from influencing factors X. So we have the input X and outcome Y, and we want to find a relationship between them. We can model it as this. And just note that we can always have the uncertainty, and I'm going to denote the uncertainty with epsilon. We can also call it the random noise. Uncertainty. And Fx is the predictable pattern. And we have the past data, like the temperature, weather, or maybe day, and the number of rentals from the past. So here, let's say we have this plot, and we want to find the trend here. Here in this one, the pattern is a line. And how do we predict the tomorrow? Let's say tomorrow is gonna be 9 degrees. The weather is gonna be 9 degrees. We draw a vertical line like this and stop where it cuts the trend line and then go to the y-axis. And here it comes to 25. So we say that we will need to have at least 21 bikes tomorrow. But we can here in this case we have the labeled data, but one can ask if we have only raw data unlabeled, can we still learn from this data? And in this case, it's going to be called the unsupervised learning when we have only the raw data, and we are going to try to find patterns using only inputs Y. As you see in this graph, we are going to color it, or we can say we are gonna cluster it and try to find different clusters. And we already discussed, in fact, the supervised learning in the previous slide. We say predict an outcome Y from known inputs X. Let's talk about them in more detail. So this was the supervised learning, our bike rental model. And as an input, we can have the temperature, weather, day of the week, and the outputs are number of rentals. So here the goal is to learn the relationship between X and Y to predict the future rentals. One can say it's like using the yesterday's data to forecast tomorrow. And the next one is the unsupervised learning. And we can ask this question for the same bike station. How can you group bike stations based on similar rental behavior? Here, in this example, let's say we have the average rentals per day, and the station capacity. And we ask, okay, what can we deduce from this data? In fact, we can discover hidden patterns or cluster. Like in this example, we clustered the dots. Like here we have the yellow, we have the green one, and we have the purple one. So we have these segments: low usage, medium usage, and high usage. And this can help us to optimize resource allocation or maintenance schedules. So if we summarize, in this case, what we do is we discover hidden patterns or clusters in the data. And can say we can identify stations with similar usage. And here we don't know the outputs. We don't know the outputs. And now I'm gonna talk about the two main approaches to find the pattern, to find the model. And so in this case, our question is, should we assume a shape for f of x or let the data decide? And for the parametric methods, as we discussed, here we have the same plot again. In this one, we assume that there is a line here, and it's a parametric method. We say specific, we assume a specific functional form. For f of x, and for the non-parametric method, we make no assumption about the form of f of x. Let's dive into the parametric method. This is our previous plot. Again, we have the temperature and we have the number of rentals, but here in this one, we assume that we are gonna have a line, a fitted line, a fit line here. In this case, we assume that it's a linear regression, and we try to find the best line. Let's denote the coefficients beta 0, beta 1. And what are the advantages? This is simple, interpretable, and fast. What are the cons? May underfit if the true relationship is complex. For example, if it's not linear, we might not find a nice line. Let's go to the non-parametric method. Again, I have the same example, but in this one, we don't make any assumption about the functional form of f. We can give one example for that. It's called the k nearest neighbors. Here, you determine the k. Let's say your k is 3, and for every point, you look at the closest 3 points, and then if it's in this case, it's by number of rentals, and I'm gonna just take the average of those 3 points and assign a point here. Again, when we want to make a prediction for the future, we look at the x-axis. Let's say the temperature is 18. We come here. We look at where it cuts, and we go to the y-axis. Here it says 42. So we are gonna need to have at least 42 bikes. And what are the advantages of this method? It's flexible, can capture complex patterns, but it requires more data, and it is less interpretable. All right, now this was all for today. What did we do? We learned that statistical learning studies how to estimate F from the data. We learned the two main settings, supervised versus unsupervised, and we discussed the approach, parametric and non-parametric. And what's coming? We will dive deeper into supervised learning. We will discuss the regression, classification, model evaluation with train and test split.